This is netstack.fm, your weekly podcast about networking, Rust, and everything in between. You are listening to episode 21, recorded on the 3rd of January 2026, where Glenn has a conversation with Tom Houlé, a core contributor to the Rust GraphQL ecosystem.
Welcome to another week of netstack.fm. Happy New Year, everybody. We are now 2026, and my first guest of this year is Tom. So I'm very happy that you are our first guest, and you are actually the perfect guest for the topic we are about to cover today, which is all about GraphQL. But before we start with that, could you perhaps introduce yourself a bit?
Yeah, thank you for having me. So I'm Tom. I'm in Berlin. I've been doing stuff around Rust and GraphQL for a long time now. Rust, basically, I learned a lot of the systems programming I know, reading RFCs back before Rust 1.0. GraphQL, I got excited at the general excitement when everybody was learning about GraphQL after it got open sourced by Facebook in 2015. I was working on a pretty run-of-the-mill SaaS B2B marketplace kind of product, working on both the front end and back end. We had pain points around that, and GraphQL was a huge hype cycle back then, if you were paying attention to the API space. So I got into that. It was also shortly after Rust 1.0, so we got into building up the Rust open source ecosystem around GraphQL, because there were very few crates and like every gap needed to be filled, and yeah, that's like a good thing at the time. So that I joined Prisma, also from GraphQL at the beginning. Doesn't have anything to do with GraphQL right now, but they used to do JSON RPC over GraphQL locally as in a library. That was a bit of a weird architecture, but that's a topic for another discussion, I guess. And today I'm working at GraphBase. We're building GraphQL federation solution. We'll get into what that means certainly in the course of the discussion.
Yeah, very exciting. And indeed, I remember very well the hype, and when it came up, it was very exciting, even though I don't think most people really knew what it was solving, but they felt like, based on their experience with like REST APIs, like it felt like a refreshing take on that space. And I also remember like many big API services which already had like HTTP REST APIs suddenly also introduced like a GraphQL one. For example, GitHub, I remember, had one. But what I also seem to, if I look at it now, like a lot of the hype has faded away, which is perhaps for the better, because it means that we might focus on what it's really good for. Can we get perhaps a bit in the history there? You already said Facebook was the one introducing it. Like, why did they introduce it? Like, what was the problem that they were facing and that they couldn't solve with, for example, REST APIs?
Yes. So that the origin story is around 2012, 2013, I think, at Facebook. They were working on the mobile apps. They had web apps. They rewrote it to native. At the same time, they noticed like they weren't efficient in the way they talked to the API. And so it was really purely the application development and front-end teams who were working on that. And in particular, I think the iOS app. And what they noticed is basically they were sharing endpoints, REST endpoints with other teams and fetching more data than needed. And then they were fetching endpoints, data from multiple endpoints and joining it in a client. And in general, it didn't meet their goals in terms of application performance, efficiency, like utilization of server resources and all that, and the user experience as well, like having everything loading at once. That wasn't a great experience. So that's when they came up with GraphQL, and it was built. That's going to matter later, but the original GraphQL server implementation was fetching data from cache. It wasn't like doing expensive queries. So it could do a lot of small queries, and that's reflected in the GraphQL execution model that we see most of the time. where it's a problem that's known as the n+1 problem in GraphQL, in the GraphQL world, where if you're not careful about how you implement your GraphQL server, you're going to end up doing many queries, multiply it every level of nesting. But I'm getting ahead of myself. So Facebook started that in, I think, 2012, 2013, in their iOS team. Sorry, that was tied with React back then, which also was very new and that had a lot of hype around 2014, 2015. They actually announced the open source GraphQL, the open source of GraphQL, so the spec and the implementation at a React conference in 2015. Sorry. Yeah, and from there on, the community really started picking it up. And at this point, with like this, that's spread. Other companies were doing similar things. I think, for example, Netflix had Filecore, which was a very similar kind of query language and technology, and they migrated to GraphQL. There's still a very big GraphQL shop to these days. And of course, a lot of open source work followed in different ecosystems. Yeah, after that.
Okay. Yeah, and like generation of code and tests and client servers, was it always since day one part of the deal?
Yes. So the big things GraphQL brought to the table 2015 were, like you said, the type system. So it's a well-defined way to document and type your API. So you have schema that has defined types, that has defined semantics. You have unions that are kind of like enums in Rust. So some types, you have interfaces, you have enums, which are really like simple value enums. You have input types, output types. It's a full schema language that's very well defined. That's also extensible. You can add your own scalars, like you have strings and ints and floats and all these kind of things by default. But you can add datetime scalars. You can add anything and with your own semantics on top. So it has so that type system. It has a very well defined execution semantics, so validating a schema, validating a query against a schema. So that lends itself very well to reusable tooling that's consistent across different languages, and that's reusable across APIs. So you don't need to invent an API explorer or a documentation generator for your own API. You just use an out-of-the-box GraphQL one because that's all standardized and you're going to work with any GraphQL client and any GraphQL tooling out there. So that's a big talking point. So to go back to the strong points, we had that type system that is well specified, and that's as a language, it was a solution to the pain points at the time where people were building React apps, and they were using that for that RESTful style of APIs where like every time you wanted to make a change, you had to add an endpoint or modify an endpoint. And then you had multiple clients that needed different data from the same endpoint, and you added a bunch of things to the endpoint. And then you needed multiple endpoints for the same page, so you joined in your client. At least that's how many people were doing it, not optimal. GraphQL addresses these two things in that you can you fetch exactly what you need. So if you have never seen a GraphQL query, it's its own language, but it's a very simple language. And to give you a visual idea of how it looks like, it's like a nested JSON object where you just specify the keys and not the values. So you have a bunch of curly braces and a nested structure, and you specify the fields you want. And there's no kind of wildcard style of operator. You specify the data you want, and you get that and nothing more. So that took care of the overshape fetching side of things. The other thing is since GraphQL types are linked, so that's the graph part of it. So if you have a user, you're on a social network, you have a user and they have friends, it's a list of users. So that's a lazy list of users where you can select on each friend the fields you want. And you're walking the graph of relationships that way. You don't have like foreign keys and user IDs to join and do that externally. So that took care of the joining part of it. So that's all done server side now instead of client side. Those were the big talking points, I think.
Yeah, and I found it very exciting, especially the part where you say like you can fetch just what you want and not have everything, because as you said, over time as these companies grow, they keep expanding like how much data they expose, and then you're just getting everything each time, even though you might just need like a single field, which is a bit ridiculous. And neither do you want like a million endpoints. It's also a bit ridiculous. That said, what I noticed after many years of GraphQL being a thing in the world is that more and more, especially bigger companies, weren't from a client side, not really anymore sending queries, but I forgot what it's called, like persistent queries, like where they were just
Persistent
sending
queries,
like
yeah.
a hash or something. Can
Yeah.
you talk a bit about that?
So that's definitely not, that's still GraphQL, and that's the recommended way to do it if you have basically any other case that's not a toy project and that's not a public API where any client may query things. It's recommended to use persisted queries. That's also called trusted documents now. That's evolving towards that, and that's going to get more and more standardized. So what they are is, instead of sending a query that can be a pretty large text document inside of a JSON object, you send an ID basically. That's most of the time it's a hash. Used to be MD5 in Relay, now it's SHA-256 pretty much anywhere. But really, you need to know which query you're doing. You send a hash of the query, and the server has a list of persisted documents, and from the hash, it can retrieve the query and execute that. That has a bunch of performance and security properties that you really want. Performance-wise, you're not resending the query. You're not revalidating and replanning it. So because every time you get a query, you have to parse it. It's like SQL in a lot of ways. Like you send the text queries, it can be big, that can be complicated. You have to parse it, validate it against your schema, and then execute it. So you have at least the parsing validation step. In some cases, you even have a query planning step that can be reused and cached for that. So you're caching things on the server side. You're not sending a huge query. And I think that's I may be forgetting things on the performance side, but that's a big one. And on the security side, obviously you can lock down what your API accepts. So since you have all that flexibility on the client side to execute, like to query whatever part of the schema you want and have very, very queries and very expensive queries, having trusted documents or persisted queries, you can lock down and say, okay, from the the production endpoint, I only want persisted queries, and the persisted queries are uploaded from CI. Typically, you have your queries in your client. You have your mobile team, iOS team that develops the app. They have their GraphQL queries. And in CI, as they deploy a new version of the app, that gets uploaded for the server to pick up. And then both sides have the reference to work with. And then you can say, I only want to execute persisted queries. And then you don't allow arbitrary queries. It's only the queries you've allowed for your apps. And on top of that, they are not visible. So someone who's looking at the traffic from their browser or inspecting their phone traffic, they can't see the contents of the query.
No,
It's
but
just a
of
hash.
course, as your response reflects the query, then
Yeah,
you can of
obviously,
course
yes.
still guess the query based on that. But okay, but I don't remember. I don't recall it seeing in the beginning. Like I only started, I started seeing it like I don't know, since 6 years ago, 5 years ago. Before it didn't really seem to be a thing, or was it always a thing and it just wasn't adopted yet?
Persistent queries. The problem is, it's like I said, there's a whole process with like you have to lock down your server. You have to also allow some flexibility for development. So you have development environments where it's not enforced, and then you enforce it progressively. And there's a lot of room for errors, and it's a lot of logistics. Like obviously that adds steps to a CI where you have to compile these documents, upload them before you deploy, and make sure you don't deploy something that hasn't been picked up by the server yet. So there's a lot of logistics. It's complex to adopt, and that's why not everybody does it. But it's definitely, for the companies that have the option, something they should do, and that's really encouraged these days.
And so can you maybe discuss a bit or explain us how exactly this looks like from a developer point of view? Like let's say, okay, I have a mobile app, and I let's say I don't know, I want to fetch specific kind of data. So normally I would do that with like this query, but so how do I do that? Is that in development also used, or is it more like you have this query and then somehow something automatically turns this query for production use in a hash, or how it works?
Yeah, so it used to be that you would write your GraphQL query and then put it in a text file in your app, and that was pretty straightforward. Then at runtime, you would send the GraphQL query as it is. Now, how the big client libraries, and we should really get into that because they are a lot more involved and complicated than an RPC client library or like a REST client library that talks to an API that's not that's regular one. These clients are really heavy, and what they do in particular, I'm going to talk a lot about Relay because that's an example that is the most popular one in the Node and TypeScript world. There's other ones, but they are taking the same directions. So what these frameworks do is they compose the GraphQL queries for you. So you have typically components, could be mobile components, could be React components, could be something else. And every component is going to define what's called a fragment. That's part of the GraphQL query language. And that's basically a piece of a query. So you say, I want on user these fields and these fields on the user's friends or something like that. And each component defines the data they need. And then that bubbles up. Like you have multiple components on the page and you have parents of these components up to the page component. And the page component is the one who's going to do the request. And what these frameworks do is every component defines a piece of the query, and they compose a whole query from that, and they generate a big GraphQL query that you don't author yourself manually, but they're going to figure out the fragments you need to render a specific page. So if you have a component in multiple pages, it's going to add to the corresponding parent queries. So they do a lot of magic. They're really query compilers. There's a Relay that's called the Relay compiler. It's also written in Rust as of a few years ago, I think. That's going to really do a lot of analysis at compile time on your queries, API queries, and generate like these big merge queries, and only pass. So you have something called fragment masking, where the client is only going to pass fields that are explicitly required by the component. So your component says, I just want these fields. It gets a huge data object physically that's from like the whole page, but it can only read these fields. And that's very useful for, so you don't have dead code. You don't have a component that depends on data from another component. So just to say there's a compilation step that's really there for a reason. And that compilation step also can generate what's called a persisted query manifest. So a big JSON object with all the queries it generated. So you can upload that to your server to use as persisted queries. It's pretty complicated. I hope I'm explaining that clearly because there's a lot of moving pieces. And that also talks to why the hype died down in a lot of use cases for GraphQL and why people aren't adopting that all the time, because it's objectively pretty complicated. There's good reasons and it works really well for some really big companies that use it, but it's complicated.
Yeah, but anyway, I would think that if you need to anyway start to worry about these kind of optimizations, like pretty much to what is core to GraphQL, not just persistent queries, but also the fact that you need to start worrying about that you're not sending too much like data. I mean, to me, it always anyway sounded like a kind of technology which is meant for big companies anyway, no?
Yeah, I mean that's like in 2015, 2016, when the hype was there, like every single like 1% project was using like not every, I'm exaggerating, but a lot of 1% projects were using GraphQL. It was also nice because it was tight. We didn't have things like tRPC and server-side rendering was really not in vogue. So that was better than making your own ad hoc REST endpoints and writing a Swagger YAML by hand, which is what a lot of us were doing. I've certainly done that. That wasn't nice.
Yeah, okay, cool. And so also if we dive a bit into protocols, as far as I know, it's always, I mean, it basically, it just defines the format of the HTTP payload, right? I mean, is it always HTTP based or is it also used on other transport protocols?
So the GraphQL spec itself is completely transport agnostic and like serialization format agnostic as well. So it defines two languages or one language, depending how you see that: a schema definition language and a query language that are pretty small languages. It's not super hard to write a parser. There's existing ones in Rust. Then there's the execution logic, which is already a lot heavier. So validating a query against a schema and executing it. And that's it for the core spec. Then you have specs beside it that define, so there's a GraphQL over HTTP spec, which is what 99% of GraphQL real world implementations use, that defines how to talk GraphQL over HTTP plus JSON. So typically a request is a JSON object with a query key that has a GraphQL query in it, and then a variables key for the variables. You can think of that as SQL parameters, like prepared statement with placeholders, and that's the same in GraphQL, except they're named, they are not positional. And then the response with data, errors, and extensions keys.
Yeah, I mean, but you say there's also like the 1% that doesn't use HTTP. Like, I mean, I've never seen that before, so can you talk about it?
I mean, at Prisma, we are doing GraphQL over JSON RPC, over standard IO. You can do GraphQL. I've seen GraphQL over Thrift RPC. That was a while ago. You don't have to. I've seen GraphQL over gRPC. It's as the sky is the limit. And also, like, what we've also implemented is, since you can replace JSON by anything equivalent, you can have GraphQL over CBOR or message pack or anything that's basically JSON equivalent, but a bit more compact.
Okay, interesting. And yeah, I mean, it definitely makes sense, especially for internal stuff, I suppose. And also now that things like H3 and more specifically Quick is more like a thing. I mean, I can imagine you can just do a lot at a single Quick connection with all the kind of streams you can do in parallel. So
that's another thing that, I mean, GraphQL is very high level, so there's really nothing about streams like you would see in a gRPC spec or anything like that. It's really request response oriented, except so one aspect of GraphQL that's I think nice and I'm missing when I use other RPC style technologies is you have a schema, and the schema has three roots. There's a query type, which does what you would expect. So it's your root, your entry points into your data graph. So you find all current user and their friends and so on. You have mutations that are entry points that have side effects. So that's what you would use a post request for in a traditional RESTful approach. And they just say these have side effect and they have to be executed one after the other, but that's a detail of the execution spec there. And that's useful. Like when you build tooling for GraphQL, it's really nice to know, okay, this doesn't have side effects. I can cache it. I can parallelize things. I can do all sorts of things with it. Or this one has, these queries have side effects. I really should be careful around that. So there's queries, mutations, and third one is subscriptions. And subscriptions are much more complicated because they are streams basically. So you say I want the notifications for my user account and I want to subscribe to that and I want to get the updates in real time. And obviously you need to take that into account at the transport level. So the earliest implementations were using like HTTP1 multi-part kind of long polling implementations. We had WebSockets for a long time and these were very, very problematic. It's still used. But really these days, the way you would do that is server-side events, SSE, because it's really the closest to plain HTTP.
Yeah, and I mean SSE is very nice. I like it a lot. And in that said, of course, over Quick it's even easier. These streams, is it also bidirectional or is it only from server to client?
No, it's really server to client. It's really, unlike a lot of RPC implementations, there's really well-defined server and client, and they have very different roles. And it's really something that's a boundary. GraphQL is a boundary, a technology. If you think in terms of Conway's laws, that works very nice at the interface between backend teams and front-end teams that don't want to be chatting all the time, that are not the same people, that can be pretty big, pretty bureaucratic. And the front-end teams really appreciate the flexibility of being able to query any data. They are allowed, obviously, you have authorization like any kind of API. They are allowed to query on the backend side, and the backend team is really backend teams really appreciate having to define the data they expose, and you don't have to define specific endpoints for specific needs, right? Although that's also something that's been criticized about GraphQL, that in general, like front-end teams had a big burdens on querying APIs, and GraphQL made life very easy for front-end teams. But it's maybe we can dig into that later. But it's really a different beast to implement on the server side, and there's a lot of caveats there.
Yeah. I mean, I think if you just implement it naively, then you don't really gain any performance. Maybe it's even worse, but we can definitely get into that. If we go to the 99% use case, which is on top of HTTP, and you were already talking a bit about, okay, it's nice, you have update, you have the query wongs, and then there's no side effects. You have the mutation wongs, there is side effects, so one is cacheable, the other one not. That said, traditionally, this is done based on HTTP header data, so that would be the methods. You would know, okay, these methods are cacheable, this one not. And same for the responses, you would also check certain headers and also things like the status code. And then we're talking about things like proxies or kind of middle boxes. I built like proxies for a living, all kind of proxies. And I must say that GraphQL is a bit painful there, because everything is a status 200 OK. Everything is basically a post request. So you have to really look at the payload to know what to do with it. I mean, was it really necessary to, for example, I mean, couldn't they just use the status codes to begin with?
So there's two questions there. There's like, is it always post request? And that's like how most people do it, and how that's been done most of the time is basically you have you typically a /GraphQL endpoint on your API, and you post your request there. Whatever the request is, it's always a post, and you get a JSON response. It's not the only way though. Like even in the GraphQL over HTTP spec, you can pass queries as a get as a parameter in a get URL. So you can take advantage of that and pass the queries that way, the mutations that way. But what you can also do is like have an endpoint per persisted query, and you pass a persisted query / the hash, and you can get or post that. But of course, the client has to, like the server, the client has to pass the right one of get or post. So it's not part of core GraphQL, and I think there's better ways to do it than the way it's done most of the time. But clearly, that's been the case, and that's been a big criticism around GraphQL, and that's definitely deserved. The other question was that of error statuses. So I'd have to check again the GraphQL over HTTP spec, but so depending on your accept header, you have traditionally you had application/JSON, and this one you're always going to get to 200, even if the request completely exploded and you get no data back. So now there's application/JSON plus GraphQL. I don't want to, please double check, but there's an other accept encoding that's standardized now, where you can return another HTTP status code, if that makes sense. So if you couldn't like return a meaningful response, and like you have server problems, you can't connect to your database, you can return a 500 now. What's important to know why that decision of the 200s initially is because since you're querying not data piece by piece, but usually you're querying for a whole page or a whole part of your application, you're doing one big query and returning potentially a lot of data. GraphQL has the concept of partial success, where if parts of the request fails, you should still get the other parts. And that's where you really need more than the status code to communicate if a request was successful or not. Like maybe like most of your page loaded, but there was that component that's one service that's down at the moment, and you get null there, get an error that specifies in the errors array in the response, and you still get a 200, and you can still show the rest of the page. At least that's the intention. And there's still iteration around that. That's actually one of the big, if you haven't followed GraphQL and you remember like the null bubbling issues, where most of the things would end up getting null because If you have an error, that's null. But if the field is not nullable, then that has to bubble up the tree. That's fixed now as of this year. Last year now, 2025, with new parts of the spec. So yeah, that's constantly being iterated on, improved, and there's new ways to do things all the time.
Yeah, fair enough. Yeah, and actually the partials are pretty cool. That said, I would think you would still be able to communicate very easily. Like, okay, 200 okay is like everything is okay, and then it's not like I know all the HTTP status codes by heart, but I would think there is at least one suitable that could say like this is a partial, so you wouldn't cache it. Still, you would accept it from an application point of view, but at least in some kind of I don't know, proxy, you would at least know, okay, it's not a 200, so I'm not gonna cache it, even though it might be partially successful. And
that's a very good point. Like, yeah, especially if you have just one GraphQL server that's not doing any kind of caching. Like, lots of people are using GraphQL gateways now that do caching at the GraphQL layer.
okay,
We can get into that, but
yeah,
definitely
okay.
a very good point.
Yeah, I mean, yeah, that's it. I mean, I never had the fortune or luck to work in a team that probably utilizes GraphQL too well, and then I usually just like I see a lot of traffic in different industries, but mostly from I don't know, like an opaque proxy point of view because of caching, security, data extraction. So yeah, that's just usually how I see it and observe it. I've tried to use it in the past actually as a like for some web services, but I think I don't think we really needed it. I'm pretty sure it was just part of the hype, and it was like cool at the time. And I guess we were just tired of REST APIs, even though we were also not really doing REST probably all too correctly at the time. But yeah.
Definitely a learning curve. Like, you wouldn't think there's a community around an API technology like that. There's definitely a lot more community around GraphQL as there is around something like, say, gRPC, because there's also a lot more culture and like solutions and like lots of more things built around it. Like an GraphQL client, like the proper GraphQL clients that modern frontends use these days, are a lot fatter and a lot more complicated and do a lot more things, and they're fat for good reasons than a gRPC client, for example. Like, you have built-in client-side caches in there that are normalized and that update. We can get. I think it's probably a bit too much to get in there. But my point was, there's a big community, there's a big learning curve. Like, you can look at all the videos from GraphQL Conf, that's every year, for example, this year, and you see that every company has different ways to do it, but still they're working towards common solutions, and there's a lot of engineering happening there.
Yeah, but I mean, I mean, I would expect it as a big community, right? Because in the end, it's touching front-end and back-end in the most accessible way that technology is. So I would say most developers work in that space anyway. And I also remember since quite early on, it has quite good integration into all these front-end frameworks like Vue, React. I mean, I'm not a fan of it, but if you're already using those kind of frameworks, then I imagine GraphQL is kind of nice because, as far as I remember, you can just hook it directly into your, I don't know the names, but like I would say widgets or components or whatever you call these things. So yeah, as a front-end developer, it's probably like a blessing, and I imagine a lot of people in the community work in that space, no?
Yes, yeah. I mean, frontend is like, there's a lot of activity there, and definitely that's often the front-end developers who push for it, because on the back end, maybe we can get into that shortly. Like, you don't know the data the client is going to require, so you have to rethink about like how you resolve these queries, and that can be done very inefficiently, very easily. And there's a bunch of caveats around like authorization. It's definitely a different beast, and you need a GraphQL framework to implement that. In Rust, there's async GraphQL. I think that's the option, like, the current option for writing GraphQL backends. And the way you do that is you write a resolver. So you have types and fields, and every field is a function, basically. And then you have to make sure that resolvers are going to get call many times, but if you call the database in a resolver, that's the n+1 problem we just mentioned. So you really have to be careful around batching things and at runtime being sure you're not going to do too much work.
Yeah. Okay. So that's very interesting. So before we dive into that, like what is the most recommended way, or maybe there's none, but like, should you write the spec file, or would it be fine to say my server is the truth of source and I generate some spec based on that? I don't know, like, what is the usual way?
Yeah. So there's code first or schema first, and there's actually the approach both on the client side and on the server side. On the server side, there's definitely frameworks like there's GQLGen in thinking Go, which is a pretty prominent example where you write a GraphQL schema and then you generate Go code from that, and then you fill in the interfaces. In Rust, I think GraphQL is the other direction, and like most of the popular frameworks in other languages are also the other direction, where you write Rust code, and from that you can generate a GraphQL schema. It represents a GraphQL schema, and then you have a function that takes your root types and that generates a GraphQL schema. So code fast is definitely a very popular approach, especially on the server side. It's the most common approach.
Are there like problem spaces or use cases where one is better than the other, or like, I mean, what do you prefer?
Yeah, I think it's very much a preference. Like if you go to the client side in Rust, we don't have these super elaborate clients for our client applications because there just hasn't been as much like activity and interest there. There's two Rust clients for GraphQL. There's GraphQL client, which I started a long time ago. That's about you take GraphQL queries written in GraphQL as files, and that generates Rust types. That was implemented as a derived macro back when derived macros were new. So you say in your derived macro, okay, this struct matches that GraphQL query that's on the file system, and that's going to generate a bunch of Rust types for the response and the variables. So that's a schema first approach or a query first approach. And there's another library in Rust that takes the opposite direction. That's called Cynic by Graham Cooper. Excellent engineer, excellent library. That's the opposite approach. So you write Rust types for your response. So you say, I have a user type, and on the user type, so it's a struct with a derive or a proc macro attributes on top. And you say on user, I want the name, that's a string, and then I want the friends, and that's a vec of friends. And on friend, you select something else. So you write these structs, and from these structs, Cynic compile time generates a GraphQL document that's going to be sent across against your API. They both have, like both approaches have things that are very nice about them, and aspects everybody agrees they are. Like it's definitely a lot less intuitive to write your GraphQL query as Rust structs and the error messages because it's proc macro heavy. But at the same time, if you generate Rust structs from so in the other approach, the GraphQL client approach, if you generate Rust structs from a GraphQL query, that ends up getting really ugly because that's often very nested. You have to auto-generate names for all of these structs. So they take name from the path they have in the query. They can get very long. On top of that, like I didn't get into that, but the shape of the objects can be a bit dynamic because you have these interfaces and all that. So you have enums that are suddenly flattened and all that. And the worst part is all that code is auto-generated. So you have to so hopefully you have good IDE support to discover it. But it's really a lot of auto-generated code that's not pretty and that you have to interact with directly if you want to get the data out of it. So all the approaches, have their pluses and minuses. I can't say which one is best, honestly.
Yeah. But what I'm getting already is like, okay, from a frontend point of view, from an optimization point of view, like it's pretty awesome. But from a server point of view, I mean, first of all, it's already quite tricky because the generated code, whether it's from a spec or because using a lot of proc macros, it's gonna be not the prettiest. And then secondly, which I now also want to get into, like it's also not all that intuitive or easy to design or make the most use of what it gives you to keep it performant. Because I mean, let's say you have your very beautiful GraphQL API, and okay, you can get partials, etc. But to implement that, I imagine a lot of companies will just fetch the entire thing and then just select the things it needs to, then send those partials, and okay, at that point you can cache that, and so you will save it for next time. But caching has its own issues because some things just need to be fresh, which means in worst case you're anyway each time fetching a lot of data, and you're only saving a bit of the network time where you don't send as much data back. But anyway, on a database pressure point of view or whatever, you are still fetching a lot of data there. So are there like good resources how you can optimize there, work there? Because I mean, I imagine it's a very different kind of way of working that you have to learn.
Yeah, definitely. So there's three approaches to that. There's like the ones most users of GraphQL are taking on the server, which is when using one of these frameworks, writing your resolvers, and you have a user.friends, for example, in a social network, and you're going to have a SQL query that's so typically the way they would do it, it's like the most general way that's decently efficient. But definitely, if you had an RPC point where you knew what data you're getting, you could do it much more efficiently. Is you would get the user's friends' IDs from the database, and then you would leave it there, and then every every user would then be in charge of returning the rest. And you use something called a data loader, where you say, I want these records. So say, well, that's not a good example, but say your profile picture is in a different table. You fetch a list of friends. Okay, you have then 20 friends, so 20 user objects, and you have to resolve a profile picture on each of them. If you did that naively and in the user.profile picture, you went to the database, you would have 20 queries fetching the profile picture for each of these users at that point in the query, which, as you can imagine, is really not a good idea. So you have something called data loader that's at runtime. You say, I want to batch load these, and then it's going to, so in Node.js, it's an event loop tick, but in Rust, it's typically a timeout where it's going to wait for a certain time or wait until that these async functions yield, and then fetch all of that from the database and then return that to the original callers. And that's decently fine. You're avoiding doing too many database trips, but it could definitely be a lot better. Also, you have a lot of query validation, parsing, and coercing logic that wouldn't need to be there in something like gRPC API. So there's definitely a runtime cost to that. What I've described is implementing manually a GraphQL API, and that's what most teams are doing, even at very big companies. They have their own frameworks and all that, but they do that. Second approach would be, I have a GraphQL query. I'm going to, so say I have very well-defined services that have their responsibilities for the data, or I have one database. I'm going to resolve the whole query at once. I'm going to do one giant SQL query that's going to query everything I need to resolve that GraphQL query and return that as one JSON blob. And that's possible. That's definitely not something you want to do for your own project. That's because it's kind of complicated, but lots of, so the first who did that were Hasura, I think, which was basically, you give us, their product was, you give us a GraphQL, Postgres database, we generate a GraphQL schema from it, you put Hasura in front, and basically we can resolve any GraphQL query in one Postgres query against that database. So this, you can also already see the problems in terms of load management and like authorization. You then have to embed your authorization logic as row level security or something like that in Postgres. So it has its issues, but it works. Like we have something like that at GraphBase as well. There's PostGraphile, so there's different companies doing that. And there you don't have the efficiency problem to the same degree. Obviously, you still have the parsing and the coercion and all that, but you have one database query. That's the second approach. So first approach, implement manually. Second approach would be these auto-generated GraphQL APIs that have some kind of query language they translate to, and that can then have a query planner that executes things efficiently behind that. Third approach is GraphQL federation. And that's something that's picking up steam in the last years, especially in enterprise circles, where the usual the original case for GraphQL Federation was, I have multiple GraphQL APIs. I just want one GraphQL API. Can we make these work together and stitch them together? It used to be called schema stitching. GraphQL Federation is an evolution of that. Where, okay, I have multiple GraphQL backends. I want one, and I want to serve all the GraphQL requests from the federated graph to these microservices, basically. That evolved into something that got more interesting, where you now have a proper query planner that takes a GraphQL query and splits it up and orchestrates that between different services. You have directives that are annotations on the schema that allow you to do a lot to, for example, have data that's accessible to other services, but not to the clients of the federated graph. You can declaratively require data from other services. So for example, we have a product.shipping estimate field in your product service, and you need, I don't know, the product weight from another service. You could say, I require the product weight, and then the Federation Gateway is going to inject that data to service. So it does orchestration, data passing between services without services having to talk to each other. And so it does a lot of query planning and a lot of resolution there. Where that avoids you the need to write these complex GraphQL backends is that the microservices, it turns out, don't have to be GraphQL. So you could have a Postgres database federated with a REST API, federated with a gRPC API, and then the Federation GraphQL Gateway, that's the thing that talks GraphQL to the clients, is going to, it knows how to talk to use gRPC, and you declared in your schema or you generated it that you can query this data from gRPC, and it's going to talk directly gRPC with your gRPC services. So you're implementing a gRPC endpoint where you don't worry about partial responses, you don't worry about normalization or anything like that. Obviously, you need some batch endpoints if you want to do things efficiently, but you can declare that in your schema. And then the query planner in your GraphQL Federation Gateway is going to take care of calling the minimum number of services with the minimum number of round trips to resolve your GraphQL query that can be arbitrarily nested and all that. So that's the third approach that we're seeing more and more these days.
Yeah, I mean, I can see why. It sounds like the perfect solution. I mean, it's basically some kind of proxy, like some kind of reverse proxy, which has a lot of other backend servers behind it. Also can do caching, I imagine, all kind of stuff. And your teams basically, I mean, that means at that point, you might even have most backend teams not even having to worry about GraphQL. They could just think of, okay, we have my services, and as long as we resolve these queries, could be in any RPC language, we are fine.
Yeah, as long as you have to remember, like you have to somehow like offer your schema, like if you auto-generate a thing from gRPC without thinking about it, you're going to end up with an API that's not super idiomatic and all that. So you have to write some GraphQL schema language and annotations to make sure like your schema is in shape and you have the right relationships between types and all that. But that's then all strongly typed. The good thing about the GraphQL Gateway also is that it implements all these things like persisted queries and like query complexity analysis and rate limiting and all that. It's both an API gateway and kind of application server at the same time, and the query planner. So they're kind of big projects. Yeah, and you have a lot of things, the GraphQL layer that's handled by that gateway. Yeah, and that's what's relevant for this podcast as well and for the Rust community is like most of these gateways are implemented in Rust. So the first one was Apollo. So the first Federation gateway was Apollo. I always mix them up. Apollo Gateway, and that was TypeScript. They rewrote it in Rust. It's called Apollo Router now. There's Hive from the Guild. They also released recently a rewrite of their, they re-architected at the same time of their TypeScript gateway to Rust, and there's GraphBase, which was Rust just from the start.
Right. For example, if we focus on GraphBase, like what is it using? Is it using an async runtime? What kind of network libraries is it using?
I mean, like we talked about earlier, like 99% of teams are using HTTP. So top level is an Axum server. We do like take care of HTTP connection pooling and like that kind of low level details and that. But yeah, it's an XM server that has a GraphQL endpoint. You get a GraphQL request, then that gets to a GraphQL parser. Then you have the whole query engine that does query planning and query execution and all that. It's very optimized to avoid, like for example, deserializing things into memory that wouldn't be needed. So for example, we compute shapes for the response when we plan the query, and then every single piece of data that comes from so these services, these upstream services are called subgraphs in GraphQL Federation. Every single piece of data that we get during query execution is going to be fetched there, but not deserialized as JSON directly in memory as a solid value or something like that. And then with a stateful serializer that gets it directly into the response, so we go from one JSON blob to one JSON blob without intermediate steps there. So to avoid copying and deserializing things we don't need to deserialize. Yeah, so that's basically HTTP. At the network level, it's really HTTP. There's obviously these WebSocket subscriptions and server-side events, but it's really just HTTP.
And like how can I do this planning? Is it because based on, I don't know, input configuration of the ones using this federation, or is there like a lot that can just be done automatically? Like you use this federation and like a lot of it is just taken care of out of the box, and if so, how?
Yeah, so federation, it defines how multiple schemas are merged. So even if you have a gRPC subgraph, gRPC service, you will want to generate a GraphQL schema for it. So at GraphBase, we have a CLI that does that for you. Like you just pass your protobuf definitions, and it generates GraphQL API. That's a starting point. Like you can annotate things. Lots of work went into like you have gRPC, like these protobuf annotations, options, I think they are called. Translate that to the right shape of GraphQL, so you don't have to adjust things by hand. But there's like obviously some work involved in like getting a really nice idiomatic GraphQL API out of a gRPC API. So you get that GraphQL schema. You could have a service that's natively GraphQL. They also get the GraphQL schema from that. And then you have a process that's called composition that composes that into a big federated schema with lots of annotations that defines which field comes from where, which field is defined in which schema, and like which fields, for example, requires data from another schema, and so on. So there's like in the end a schema with a lot of metadata and annotations, so we can know what data to fetch from which service and which are the dependencies between these, so we can have a query plan.
Okay. And something that we didn't touch on until now, I think, or maybe we did, but certainly not in as much depth as I want to, is around authentication. Like, I mean, let's say if we would just talk about REST APIs, we would authenticate at the most granular level, probably on endpoints or like sub-routers. But as you said yourself, a lot of GraphQL APIs are just basically one endpoint. How do you do authentication there so that, I don't know, some apps can only touch this and others can touch some other parts, like maybe even within the same big like query object? That is it possible to do there, like granular permissions or whatever?
So you have to evaluate that. Basically, if you're implementing the GraphQL server this way, or like even in federated GraphQL, you would have like hooks or extensions, mechanisms to write your own code to do that. For every field in your schema, you have to define, or every object, you have to define in which conditions it's accessible. So for example, you have a user.email. If the user is myself, probably should be allowed to do it. But if the user is my friend, okay, depends maybe on their settings. Or if it's someone I have no connection to, probably shouldn't be able to see their email. So you need to evaluate that based on also the path of the use of the path you took to land to that field, and the user. So you would typically, in this case, you would have the user ID in the request context, basically from the JWT or something you would have fetched from cache. And you use that to figure out, okay, is it me? Is it a friend of mine? Or is it someone else? Which can be a lot of work, can be very slow. So there's ways to batch these calls, but in general, it's very custom. There's no standard accepted way to do that. And that's very easy, as you can imagine, to forget to authenticate things that should have been authenticated, or like you have a field where you have a type that's accessible in one way. Say, I don't know. Yeah, I don't have a good example right now, but you have a type, you implement your feature, you have one type that's accessible in one way, and you know upstream it's been authorized and validated by the parent type, but then you had and that's fine. So you don't do any additional validation. Then you add another path in the graph to that type, and suddenly you don't have the same authorization logic. So maybe clients can end up seeing things they're not supposed to have access to. So really, it's type by type and field by field. You have to be very, very defensive, and there's no accepted approach.
In GraphQL, so how I knew it, at least, I was still before the federations. The nice things was that it's a pretty open technology. You can generate code. It's like you then implement your service, etc. That all works. What about these federations? Is it something is it just all open source technology? Can people just use it, or do they need to somehow hook into some paid service? And if there are paid services, what do they offer for you that you couldn't do if you would just use the open source version?
Yeah. So in general, in the ecosystem, so to reiterate, federation was invented by Apollo. So they like basically learned and developed the spec by doing and by listening to customer feedback and that sort of things. And they have like a kind of spec in their docs, but like it's not complete. Like it's fine. Like you can write other implementations of it, but it's not like a formal spec. Like the GraphQL spec, if you go read it, it's very, very well defined and detailed and clear, and like they really thought about the details, and that's been iterated on by many people over the years. So it's very polished. There was nothing like that for federation. There's an effort now called Composite Schemas. It's a working group inside the GraphQL Foundation. You can see all the meetings. There's meeting notes on GitHub. You can see the meetings on YouTube as well. And everybody's welcome to participate if you have like interest in that. And what it is, it's a cross-vendor open specification for federation with mostly the same functionality as previous federation implementations, but with also a lot of learnings. And since it's a new implementation, better ways to do things, a few, but very, very nice improvements in that. And also, like it's seen as an evolution where you can mix and match the old spec and the new. So that's an exciting effort. It's not 1.0 yet, but it's already pretty advanced. Like the implementations are going to have to catch up with that spec, but it's the future, I would say pretty clearly, and that's completely open. So that's great. Now that's the spec of how federation should work. Now the implementations, as far as I know, all the popular GraphQL Federation gateway implementations are open source or something close to it. So GraphQL is one open source, the Hive one is open source. I think Apollo Router is open source too. Please double check on that. Yeah, so the runtime component that serves the requests, that's open source. A lot of the supporting libraries like GraphQL Composition, we have our own one at GraphBase. I think the Apollo one is also open source. They're all open source, so you don't have to worry about that. Where these companies have paid offering is the platform where you have extra schema tooling, like hosting for persisted queries, trusted documents. You have schema evolution, like schema breaking change analysis based on usage, and like workflows for schema evolution, where you can have multiple teams approving changes to a schema, and like more of these management type features, API management and API kind of evolution, rather than the runtime component that's actually going to serve the requests. So you can build a complete GraphQL Federation solution with open source. But since it's like you need multiple services, GraphQL is a lot of buy-in. It's mostly enterprise customers, and they like having the whole solution with a nice dashboard and analytics and all these kind of things.
Okay. And would they still self-host it? Like they would pay for something, but it would run within their own clusters, or would it go
So it
via
depends
some
on the
external ones? Yeah.
Sorry, depends on the vendor. GraphQL is always 100% self-hosted. Well, no, it's not. We have the managed offering, but we are focusing, like not focusing because it's working, is going to continue working. But it's like there's a managed offering, but there was a gap where the other vendors weren't doing like self-hosting quite as well, and there's a focus on self-hosting for enterprise customers that also don't want to have any data leave their infrastructure. There's hosted and self-hosted offerings yet. Other vendors are also doing self-hosted now. So it's really an option and a choice. But not all the self-hosted options are open source. Like the gateways, so runtime component, always open source, can run it in your infrastructure, always self-hosted. But the data, like analytics and schema evolution part, so the schema registries, they're not always open source.
Yeah. I mean, it does make sense. Are you still involved in the GraphQL client, or?
If you look at the GraphQL client repo, there's users, there's people contributing, there's releases not that often, and there's not a ton of activity from like from regular contributing members. And like I'm the original author, I'm still the maintainer of it, and like sometimes PR sit a bit too long, so I'm active from time to time on it, but I find it hard to find the time to work on open source. That's not part of my job these days. So that's a nice, I think it's a nice platform to call. Like if you're interested in working on GraphQL and Rust, you have ideas, I'm very, very open to contributions and people stepping into maintainership and all that. So that library is not dead. It's not updated very regularly. It's also kind of finished. It's one of these projects where, okay, there's improvements, there's bugs from time to time, but it's kind of finished. Like you give it a GraphQL query, it gives you Rust types for it that work. So there's no big push for big feature changes or new things. So it's kind of fine that it's in maintenance mode right now. But definitely could be better.
And is it possible, like for example, we have our own network framework, would it be possible for us to just generate a client with our own code with it, or is it always bound to specific client library or something?
You mean the HTTP level?
Yeah, HTTP,
yeah,
TLS, like the entire layers.
There's a built-in like optional cargo feature to use request, so request crate, to have like a complete client that's a bit easier to work with. But really, like you can build a GraphQL request without a GraphQL client. It's really, you have a GraphQL query, you build a JSON object, you accept encoding, it's application JSON both ways, and release a JSON in, JSON out. If you don't care about the types, you don't need a GraphQL client, especially if you want to write some tests or you just have a few queries. Like I just wouldn't bother with the GraphQL client. Is if you're building an app that talks to a GraphQL API, like that really makes sense to have strongly typed responses for it and requests, and that's where something like Cynic or GraphQL client would come in. But really, you don't need that for something lightweight. If you look at the request feature, it's really tiny. So it's really not a lot of code. You can do it outside the library. PR for doing it inside the library as a cargo feature would also be welcome. But it's really not a lot of code. It's one module. You can definitely plug it in, like any exotic kind of transport you can think of, or any other HTTP client.
And so for because in the end, you would, like sometimes I see, okay, they allow different kind of transport layers, but they might still bind themselves to specific, how you call that, core crates, like HTTP crates. But then you might be actually building a framework that doesn't even use that. Like, does it ever evolve there, or doesn't really matter because anyway you're just dealing with the queries and the responses?
Yeah, it's that. It's GraphQL queries in, types out. So it's, if you look at the dependencies on the core crate, if you exclude the request feature, it's really a GraphQL parser and the crates for proc macros and code generation. And there's really not much more to that. So it's not bound to a specific async runtime. It's not even bound to async. You could have a sync client very easily. So GraphQL is really high level, application level stuff that doesn't care too much about these details. Like even if you look at the advanced, like much heavier weight TypeScript clients that are really kind of API query frameworks, because they have all kinds of features, they always have a pluggable transport. So if you want to use a different HTTP client, you can.
Okay. And so, given all this, and GraphQL came from a very good start, but we had a lot of hype, too much usage, then the hype went down, but we started to get federations, which is a very beautiful solution. I didn't know about that until just what I learned from you, so seems very elegant, very cool. I would have to study it a bit more. Like, how do you see GraphQL evolve towards the future? Like, where you see it heading?
Yeah, I would have three ideas there. So one point is it's going to continue iterating because it's like the hype is finished, but the community, like I would encourage anybody who's thinking about it to just go to GraphQL Conf. Community is there, like it's used by big teams in big companies, smaller teams as well in smaller companies, but like a lot of, like I think it's found its sweet spot in slightly larger teams. It's used, it's being worked on, like the spec, there was a like irregular releases of the GraphQL spec, like every 2-3 years, 4. But now it's going to be released every year. Like you can look at the working groups. There are people talking about evolution. It's pretty conservative and it's not going very fast, but you have people meeting like every week or every month talking about proposals and evolving things. So it's a very much a live community. And I think that's just going to continue. Plus you have new people coming up with open source projects with new ideas, new ways to do things. Like for example, in the client world now, there's Isograph. That's a new take on doing GraphQL clients. So there's activity. It's going to continue, and I think the community is very healthy and kind of self-supportive in terms of activity. So I have lots of optimism around that. The other thing is federation. I think is going to continue evolving. There's like you said, like not many people know about it, and like there's not enough noise. But I think if people knew about it, there would be more usage. Like it wouldn't be. It's not for every team. It's not for every product. But there would be more usage of it because it's a good solution and it works like in big companies right now. Yeah. And the third thing is like, I'm a little less sure about that, but there's also a lot of discussion around that in the GraphQL community is GraphQL for LLMs. So if you think about why GraphQL is nice for front-end teams, it's like it's self-documented. The API is self-documenting. So you can ask the API what types it exposes and what it can do, and you can have the docs in there. You can auto-generate the docs from that. It's standardized. It's always the same. It's very well defined. So it's self-documenting, very well defined, and like lots very common. That's something that's nice for an API for LLMs. So LLMs can basically figure out how to use a GraphQL API on their own, like out of the box, and they can build their own queries very easily. That works really well. Any modern LLM I've tried that's good at coding can do completely like the same GraphQL queries you would want. So there's hype around GraphQL as an API language, an API technology that makes it very nice for LLMs to consume your API. And that's an argument that's being worked on. I doubt it's going to sway a lot of companies to rewrite their whole stack in GraphQL, but you can, with federation and with other solutions, build GraphQL on top of your existing other kinds of APIs. You don't have to rewrite all your backend code to GraphQL. So that's, I think, an interesting avenue. There's like difficulties around that, and people have come up with different solutions. I think we have a pretty good one around, for example, okay, you don't want to put your whole GraphQL schema into your context, because I've seen some extreme examples with like multiple tens or hundreds of megabytes of schema description, and you don't want that in your LLM context. So there's all that talked about MCP, authentication, authorization for agents and all that. So that activity around that, there's even a working group inside the GraphQL Foundation now. I think that's like, I don't know if it's going to pan out, but I'm excited to see where it's going and if there's going to be more adoption of GraphQL because of that.
Yeah, but of course that would mean that we need to again move away from persistent queries and towards more the original GraphQL, no?
Yeah, that is a very, very good point. Like your API has to be open if you want an LLM to generate queries for it. Yeah. Although there's, I know at least of one implementation where basically their approach to solving a context problem is you define a subset of your persisted queries, you document them, and you say, okay, that's for fetching a user and their friends. And then the LLM can call one of these. So you have the benefit of persisted queries and a small context at the downside of less flexibility, and you have to create the persisted queries, right?
Yeah. I mean, maybe you could have one query to get all those persistent queries, I guess, with a description. Okay, very cool. Yeah, it seems like a very natural way to use it. Why not? Maybe the problem is a bit that when there was the hype of GraphQL, it was talked a lot, also on all kind of conferences. Now the interest is kind of gone, and you see less of it in maybe other kind of conferences, let's say a Go conference or a Rust conference. Like, yeah, I don't even recall ever GraphQL being on a Rust conference. I mean, not that I've paid attention to it.
Yeah, and the Rust ecosystem isn't that active. Like, I think GraphQL is fine, but when you compare it to the mature Java or JavaScript implementations, there's a long way to go. And the clients, like I said, like at least mine it's in maintenance mode, right? So there's definitely more room for momentum here. At the same time, like it has a lot of real world usage, but not through Rust. I think the big use case for Rust in GraphQL is these federation gateways. But apart from that, like the real world usage is in other languages. Like you have lots of Go, lots of Java, and lots of TypeScript.
Yeah. And is GraphQL still driven by Meta, or did it become its own thing now?
I mean, that's was kind of like my what I wanted to convey with the community side is it's really community driven now. Obviously, like if you go to the GraphQL Foundation meetings, you have people from Meta, people from Netflix. They're also very well known, huge user of GraphQL and from these big companies. But really, there's no single company that owns it. Like for example, Relay is a Meta project, so it's driven by Meta and like specific implementations. But the spec itself and the ecosystem is very diverse now, and like there's no single ownership, and that's a very good thing. It's very healthy.
But then, who approves? I don't know what specs comes through. Is it like some kind of committee, or like how it works?
Yeah. So the specs, there's a technical committee that's in charge of the GraphQL spec, but so there's a GraphQL Foundation. It's part of the Linux Foundation, and it's formalized with different working groups, different meetings, a lot like the Rust Foundation. And it works a lot of the same way. So special interest working groups that work. You have the composite schemas working group. You have, I think you had the nullability working group, like AI working group. For example, another one that's very good that shows where things are at now is OpenTelemetry working group. So standardized how GraphQL metrics and traces work and look like in OpenTelemetry. That's not a sexy detail. That's not something, but it's complicated. You have a working group that works on that. Microsoft was pretty involved in that one, for example. And now we have a spec that's, I think it's going to be released, or it's just released, that like OpenTelemetry vendors like Datadog and that kind of platforms can integrate with and offer GraphQL specific insights. So it's that kind of small things that show the community is very healthy and progressing because that work is happening, and there's activity and buy-in.
It's very interesting. I mean, I'm also very involved in OpenTelemetry. We also had an episode about we had a guest from eToro, which is like a vendor that allows you to consume OpenTelemetry data. Our framework is also OpenTelemetry first with tracing, etc. So I can imagine that's very interesting. Very cool. Now that we are nearing the end of the episode, were there some things you still want to plug in, or maybe we didn't touch on a subject and that would still be nice to touch on anyway?
No. I think I've ranted a lot about GraphQL. I think it's worth considering. It's not dead. Like no other activity, there's legit use cases. It's not for every project or every team, but it's very much alive and it has its place, I think.
Okay, and then maybe specifically for the Rust community, is there something that you maybe have like a message to the Rust community that maybe like a call for action or whatever really?
Yeah, I think GraphQL is nice. Like I don't want to talk down the crate, but I think there's room for also other approaches like GQL Gen in Go. That's a completely different approach to writing a GraphQL server. I think there could be a nice experimentation. There's room for experimentation in GraphQL server side frameworks in Rust. And just to say it again, if you want to work on clients, GraphQL client isn't dead. And if you want to improve things, there's a lot to contribute there, I think, still.
Okay. Well, in that case, thank you very much, Tom, for being the first guest this year for our Net11 podcast. And I hope that 2026 might be very kind to you.
Thank you. It was really a pleasure.
Netstack.fm is brought to you by Plavayo, building secure, open, and resilient infrastructure with Rust, protocols, and purpose. This show is also made possible by Rama, the open source networking framework. Plavayo offers service contracts and welcome sponsorships to keep building and supporting its ecosystem. The theme music of this podcast was composed by DJ Mailbox. If you enjoyed this episode, don't forget to subscribe on your favorite podcast platform and leave a 5-star review. It really helps others discover the show. Thanks for tuning in. We'll see you next time for the next handshake.